Welcome to CivilizationX. The air is not the main heat reservoir. The ocean is absorbing most of Earth's trapped energy. One widely cited NASA analysis, combining CERES satellite flux data with ocean measurements, found Earth's energy imbalance roughly doubled from 2005 to 2019. At 6:12 a.m. on a Monday in late September, a night shift nurse steps onto kitchen tile, expecting relief, and gets none. Her son sleeps beside an inhaler. Her phone flashes another flood tide alert for the road to school. In 2023, Earth averaged about 1.48 degrees Celsius above 1850 to 1900. NASA's CERES satellites, Argo ocean floats, Mauna Loa gas sampling, and methane mapping satellites measure the system directly. Incoming sunlight, outgoing infrared, ocean heat uptake, and atmospheric buildup. Machine learning is now being used on top of that stack for medium-range forecasting, methane plume detection, grid balancing, and materials discovery. The issue is not whether warming is visible. It is why visible progress does not stop a planet already storing energy. Sunlight enters. Earth sheds that energy upward as infrared radiation. Greenhouse gases absorb and re-emit part of that outgoing flow, slowing heat loss to space. Before large-scale fossil fuel use, CO2 was about 280 parts per million. At Mauna Loa, monthly averages rose above 426 ppm in May 2024. That is the bathtub problem. Annual emissions are the faucet, atmospheric concentration is the water level, and Earth's removal processes are the drain. Slowing the faucet is not draining the tub. Now the perspective shift. More than 90% of the excess heat goes into the ocean, not the air. That is why a cool week, a snowy winter, or even an El Niño spike tells you less than the ocean does. Surface weather wobbles. The heat vault keeps filling. John Abraham's scale is brutal but useful. The added heat is like dropping 5 Hiroshima bombs per second into the oceans, every second for 25 years. Warmer water expands. Land ice melts. NASA satellite altimetry shows global mean sea level has risen roughly 10 centimeters since 1993. And the rate is accelerating. This is why the nurse's sleepless apartment and her flooded road are one signal. Stored ocean heat raises humidity, lifts nighttime temperatures, and pushes high tides inland. Methane sharpens the near-term problem. NOAA reported a 10.9 ppb rise in 2023, reaching 1922.6 ppb, a record annual average. Because methane traps far more heat than CO2 over 20 years, leak detection and rapid abatement can cut warming pressure faster. So yes, El Niño and natural variability matter, but they ride on top of a measured forcing trend, confirmed by greenhouse concentrations and ocean heat. Global fossil CO2 emissions still hit a record 36.8 gigatons in 2023. Better than before is not enough. As the IPCC notes, even stabilizing concentrations now would still allow warming for some time, because the ocean has already banked heat. The engineering race is compression. WMO puts the chance that at least 1 year from 2024 to 2028 exceeds 1.5 degrees Celsius at 80%. AI can help forecast extremes, find methane leaks, balance renewable heavy grids, and speed battery or carbon capture materials work. But it cannot bypass permitting, steel, transmission, verification, or unequal access to cooling, insurance, and relocation. The constraint is real. The data exists. Whether the systems built around it can act on it at scale, that is the next engineering problem.